Welcome back once again for part 3, digital locksmithing. This time out, we're going to be looking at hashing, digital certificates, and secure communication. So this is a lot of the use of cryptography and encryption that you're going to see in your daily work as a cybersecurity IT professional. Web developers need to know this stuff. Security is everyone's responsibility now in information technology. So just a reminder, I do have a textbook. If you found this video someplace else besides in my class, feel free to reach out to me and I'll be happy to get the textbook to you digitally. So let's take a look at hashing digital certificates and secure communication channels. Now, most likely, if you've done any work within information technology, you've followed some of the, hacks and the news that are happening, ransomwares, etc. There's a great example of, bad use of encryption. You know that cryptography is huge as it pertains to security. And, in that case of ransomware, used to encrypt data so that you've got to pay to get the key back. So in cybersecurity, so hashing, digital certificates, secured, they're all fundamental techniques used to protect integrity, verify identities. So we talked about authorization and authentication last time. So these are the cryptographic methods that can be used to benefit those, those techniques. So and ensure secure communication. Again, that HTTPS, the SSL, that's going to come back around in this when we talk about secure communication. So hashing is essentially, it's an algorithm, that takes an input, a message, a file, whatever it is, right? And returns a fixed size string of bytes. So the output is typically called the digest. And common hashing functions are SHA-256, MD5, and SHA-3. So SHA-256, i.e. 256-bit hash values, MD5, 128-bit, SHA-3, which is the successor, can't say that word, to SHA-2. And I give you an example here. So when I download Kali Linux, right, which is the pen testing and security analyst software operating system with a lot of great tools. You'll learn Kali Linux as a cybersecurity professional. Every time I download, Kali Linux from their site, i.e. offensive security site, I download the software, then I use PowerShell to figure out what the hash is to make sure that that file that I just downloaded is exactly what offensive security intended to give me, that there was no way that it was compromised in transit or that somebody, this happens a lot. We see this happen in like Apple stores, or the Android store where, software, they break into the store, they modify the software with, say, some malware, they put it back up there, you buy what you think is a legitimate, secure piece of software, and dang if suddenly you find out later that you've had it for 2 weeks or you've had it for 2 years, that your version may be corrupted with malware or a virus or whatever the case may be. So when you're downloading software, folks, find that hash and check it carefully. So definitely I have my students practice this on files. Non-repudiation. So this is the inability to deny taking an action, such as creating information, approving information, right, or sending and receiving a message. So you'll see this in, say, a digital signature, which we're going to talk about. You get a document, you digitally sign it, right? And your digital signature goes with that document, meaning they know it was you. And there's no way to get around that. That's basically what non-repudiation means, okay? The message digest is, again, the digital signature that uniquely identifies the data, right? So it's created based on your signature and the data, and I've got an example coming up for you here, okay? So the application of hashing, verifying data integrity. Again, I gave you the example. I download Kali Linux for my Raspberry Pi 5 and I make sure that that hash matches exactly. Remember, just changing one bit in a file, whether it be an executable file, a Word file, whatever, changing one bit changes that entire hash, okay? Changes that digest completely. So give that a try. Open up a Word document, maybe do it on, I have my students as a participation assignment, do it on this week's chapter. They've got a Word document, they've got a chapter, they run PowerShell, the find hash on that file, it gives them the hash, they go in, change one period in the entire file of 15,000 words, and the digest changes. So we can verify, we can convert passwords into hashes. So folks, if you're not aware, passwords are not stored in plain text, and they're not stored in encrypted text because of the process it takes to then decrypt, right? Oh, I'm looking for a password for an end user. So we tend to save those in hashes. So consequently, you might remember me talking about Rockfish 2024 and the 10 billion common passwords that are in that file. It's not the password itself in, now you understand, plain text. It's not the password in ciphertext. It's hashes. So it's that password hashed, okay? And that way we can go through, we can get the hash of a password and try to match those hashes. That's how we, oh my God, dad joke. That's how we hash it out, folks. So protect actual passwords, even if the database is compromised, because again, we've hashed those passwords, all right? So digital certificate is an electronic document that verifies the identity of a person, device, or organization. Now you see these in SSL or TLS certificates. SSL has gone by the wayside, but everyone knows SSL, so we now call it SSL TLS, as you'll see in a minute. So how do digital certificates work? Well, they're issued by a trusted third party, a certificate authority, okay? Or you can set up your own CA, okay? But those aren't going to be trusted over the internet, but those would be trusted internally of your network, right? Because you're retaining that CA, if you will. Verifies the identity of an entity, enables secure communications, contains the entity's public key, right? Which we don't care because we need the private key to decrypt. We don't care if they encrypt it with the public key. We need that private key to decrypt when the information comes to our servers. So we establish that trust communication. Client connects to the server. Server represents its digital certificate and says, see, I am legit, right? Now you still have to be careful because, although SSL certificates are given out, matter of fact, I think Chrome might have just a while ago gone to, if you go to a site that isn't using an SSL certificate, they warn you big time. They don't even take you there, because the transfer data is not encrypted. So you have to go through, steps to say, yep, I do. I trust. I understand the risks, right? So client verifies the certificate's validity. That's your computer verifying that the certificate on your bank site is legit, right? It's valid. If for some reason it becomes corrupted, we can revoke it, which means it's no longer valid. So that works as well. Okay, that's another security mechanism. So if it is valid, public key to encrypt this, encrypt the session key. So what that is it's a key used just for that session. From the moment I log in and authenticate to my bank till I close that session by logging out. Always log out, by the way. Don't just close your browser. Get in that habit of logging out so that if you accidentally leave your browser open and go do something else, you haven't left your bank account open, right? So get in that habit. Habits as a cybersecurity professional are key. So anyway, that session key gets encrypted, and that's the key, a public key and private key that's used just for that session. So the only time that the hacker has to break that is while we're using that unique key, Okay, and it ensures both authenticity and data security. Digital signatures, on the other hand, which we briefly talked about, digital signature, it's a cryptographic technique, again, to validate the authenticity and integrity of messages, software, digital documents, by you signing a digital document, for example, in Adobe Pro, as we'll see in a second. Okay, how do those work? Well, created using the sender's private key, part of the pair of cryptographic keys, right? The other being the public key. Sender uses their private key to generate a unique signature for a document. The recipient verifies that signature using the sender's public key. So again, this time we're retaining the private key, right, that is associated with that digital signature that I create within Adobe for myself. It is unique, right? And I, again, can revoke that at any time if I think somebody got a hold of my digital signature, okay? So its valid signature confirms, again, non-repudiation, which means, hey, I looked at it, I signed it, and I can't get out of it because I digitally signed it, right? So I can't tell you I didn't look at it. I can't tell you I didn't sign it. Integrity, right? The document hasn't been altered. And then, of course, authenticity as well, which means the document wasn't modified in transport through, say, a man-in-the-middle of attack. So examples of use of digital certificates. So secure websites. Again, pause, read through this. Okay. Ooh, I just noticed I got to change something here. There we go. I made the mistake of changing the master configuration of my PowerPoint, and it messed this all up. I spent almost 4 hours reformatting this PowerPoint to get it out to students and get it out to you folks on YouTube. So key examples, again, secure websites, email encryption, securing network traffic, and software signing. So Microsoft is a great example of this. So when we look at this, digital certificates in Microsoft, so uses third-party and self-generated certificates. So again, through Windows Server, we can fire up a certificate authority to encrypt traffic between two devices in our secure network. Okay, but that CA is not going to be valid on the internet. So if data needs to leave my network, I need to get a third-party certificate from a recognized certificate authority to use for that purpose. Okay, certificates used, inside and outside within the DMZ, for example, maybe from inside the trusted network out to the DMZ through the firewall, still encrypting that traffic, always a good idea. Internally between a Windows 11 client and, say, the Active Directory server. Okay, so domain administrators can map user-specific certificates. So certificates just for that user, right? An even higher level of security utilizing Active Directory and the alt security identities attribute. So enhance security. Digital signatures. So where do we see these used commonly? We see these used by Microsoft when it comes to third-party software, right? So you download a piece of software, Microsoft goes through and says, hey, wait a minute, do we have a digital signature? Do we trust this software? So my favorite example of this is when I connect my Alpha Wi-Fi network interface card, to a Windows machine. Okay, and I want to install it, it'll pop up and say, whoa, wait a minute now. We do not trust this driver. This driver has not been signed. Are you sure you want to do this? And because, of course, I trust Alpha, I trust the driver, I go ahead and install it. But you can understand from an end user standpoint, this ensures that they're not getting that malicious software. Okay? All right, so then, as we look forward here, let me just quickly go in there. So their uses, again, right, third party, just to reiterate this, ensure software can be used safely, reliably. Software out on the Apple Store, for example, hasn't been corrupted with malware, for example. The example that I'm going to give you here, let me blow that up for you, is going to be this digital certificate from Adobe. So I went in, created a user called Digital Defender. that user as a cybersecurity professional. There's their email. There's the issued, right? So valid from, 7/28/24 to 7/28/2029, which means 5 years from now, Adobe Pro is going to say, wait a minute, this certificate's no longer valid, right? Most likely I'll have a new computer. I'll have to create a new digital certificate in the process. But you get the idea. So when it comes to secure communication channels, SSL, TLS, here we are. Protocols that ensure secure communication over the computer network. And we'll get some examples of this, but what's the first and foremost? HTTPS. S meaning secured, right? It encrypts data transmission between clients and servers, between two devices on the big I internet. So when I go out, between my computer and a data center that I may be accessing data in, for example, my OneDrive, for example, right? So SSL was sort of the original, the foundation of secure communications on the web, provided data encryption, server and client authentication, and message integrity. Now, what gave way to that was a more secure version, the transport layer security, but SSL has been around for so long, you'll see it referred to as SSL when really today they're most likely talking TLS, okay? It is a successor to SSL. That's why you see the terms together a lot, SSL, TLS. It's more secure than SSL, and it does basically the same thing, right? Encryption, server and client authentication, message integrity. It just does it more securely. Here's a great example of a U.S. bank CA certificate, right? So the CN is Entrust Certificate Authority. So when you connect, right, that session key is going to utilize, the encryption algorithm is going to utilize this certificate. It's going to encrypt that session key, okay, that we use to communicate while we're in that session, from the time I log on till the time I log out. Make sure you're logging out, not just closing the browser. But here's the information on that certificate. You can see it's only good for a year. So somebody at US Bank better make sure that they renew this before the expiration, or no one's going to be able to get into their website to do banking. So again, applications of this technology: HTTPS, higher and more secure VPN connections. Sorry about that, folks. So for VPN connections, email servers, all examples of utilizing secure communication channels and SSL. Now, if you are a student of mine in a class where you're taking a class from me and there's performance points, here's an opportunity for 15 performance points. And that is, read that case study within the textbook on blockchain. Great case study. Send me an MS Teams chat. Don't forget the class number in there, and just do a brief, very brief summary. Not an executive summary, even briefer than that, on that small mini case study within the textbook, and you will earn 15 performance points. For the rest of you, it is a great read to understand a great use of cryptography and encryption in a modern day system of accounting, if you will, as it pertains to the ledger securing transactions within cryptocurrency. So folks, that's it for this section. I look forward to seeing you in section 4. In section 4, we've got all these security keys. We've got to manage all of them. We're going to talk key management. We're going to use whose framework are we? Oh, that's right, Splunk. We're going to use Splunk's key management framework. We'll also take a look at cryptographic attacks. And in part 5, we'll look at legal and ethical issues and the future of cryptography. I'll see you in the next video. I hope you're learning a lot. Reach out to me. Let me know always what I can do to improve these videos and thus improve your learning. Take care. Have a great day. We'll see you in the next video.